Number E, the amount of energy in joules radiated in 5 minutes. Okay, so now let's go back to what we knew. The amount of energy, part E, energy, Q. So we know this, right? dq over dt is phi E. So I am looking now for QE, which will just be phi E times time. And time, it's asking me it's in 5 minutes. So what should I do for the 5 minutes? Convert it to seconds. 5 minutes is how many seconds? 5 times 60? 300. 1.68 watts times 300 seconds.
I only heard 500. I was like,
So wait, what is it? 504?
Yeah.
yeah.
What? Watt seconds or F? Irradiance received by the eye 100 centimeters from the bulb if the pupil is open to the diameter of 6 millimeters. Okay, so how do we do this? What do I know? Irradiance is power divided by the area of the eye. That means this is going to be phi E divided by the area of the eye, which is delta A of the eye. Note, this phi is not the same phi as it is emitted by the source, right? Because this is only a part of the entire one. So how do we figure out the power that the eye is receiving? Very carefully. So this is, I'm going to change this to call it phi of the eye. Good? So I have renamed it. How do I find the phi of the eye? Woo. Haha. I have to pay attention to the fact what part of the source is actually even getting to the eye. And how do I do that? So I have to do power getting to the eye times the solid angle of the eye. So if this is my bulb that's radiating outwards, right? And this is my eye that is far, far away. That's about what, 100 meters away, they said?
That was 100 centimeters.
Oh, 100 centimeters.
Not that far.
Then the solid angle that that pupil is receiving is this one. So first of all, I have to figure out the solid angle for the eye. And the way I will do that, it will be defined as the area of the eye divided by the distance. Pi r squared divided by, what's the distance? 100 centimeters. Oh, I called it 1. This should be 100 centimeters. So what was the radius of the eye that they gave me? So how do I convert that? That gives me r equals, right? Because the d that was given was 6 millimeters, right? And then that means r will be 3 millimeters. So then r will be 0.3 centimeters. So if I plug that into here, what will I get? Pi 0.3 squared divided by 100 centimeters.
2.827 times 10 to the negative third.
Centimeters. So that gives me the solid angle of the eye. So that's one part done. Number 2, the power getting into the eye. The power getting into the eye. How do I calculate that? So I calculated by figuring out the source and the solid angle. So the source is radiating at, from part B, we calculated the source radiation.
0.134.
0.134, right? Watts per steradian times the solid angle that we just measured. I messed up. Can I just tell you this is distance squared here? Which means our answer is going to change.
Okay.
That was my fault. This should be distance squared in part 1. I accept the blame for that. Wait, how do I fix that?
Change
Just change it to
3
the
Thank you. So then the centimeters will go away and we will have steradians here. And that will be 2.8 times 10 to the negative 5 steradians. I plug that value in here. Cancel this one with this one. And what am I left with?
3.79
Okay, times
10 to the negative 6 watts.
watts. Okay, now plug them into this equation and solve. So if I use equation 1 here, my EE will be, the power getting into my I is 3.79 times 10 to the minus 6 watts divided by the area of the I. Pi times 0.6, oh, 0.3. You're right, 0.3 squared. That will be a pretty tiny number.
0.34 times 10 to the negative 6.
Watts, this would be centimeters squared. Oh, I'm glad we never converted it. So out of all of that radiation, the amount that's getting to our eye is kind of tiny.